Hi, welcome back to another video. So in this video today we'll be looking at hydrocarbons, right? What hydrocarbons are. So hydrocarbons are compounds containing only carbon, C, and hydrogen, C atoms, right? So we can just put there that this containing C and H atoms, right? So these are what we call hydrocarbons. So let's try to understand in everyday life where can we find hydrocarbons, right? To actually understand what we are studying. So this is very important because it kind of destroys the complexity of what we're learning and rather not something it's something that's tangible, right? So in everyday uses, these are our natural gases, right? So an example of this is methane. We'll get to that on what methane is and how we represent it. So methane, this is used for energy. You can use this for cooking, boiling your water, right? So of all kinds of things, right? It's we use it a lot in South Africa actually, and also used it across the world. It's also a good alternative to our electricity. So let's see. Also, I have uh, fuels or natural fuels. Some people will argue that this will be under natural gas, right? So this is what we have our petrol, diesel, gasoline. So I'm not really sure about the difference between gasoline and diesel or petrol. So let's just put three of them there, right? So we know these ones we use it for energy too, right? We can also use it for energy where we have our generators, right, running on petrol or diesel, and then we can also use it for our cars, our machinery in agriculture and also in the industries. So it shows that hydrocarbons are very important in everyday life, right? So if you understand hydrocarbons, you can understand the things that are happening around you. How does your car move? It needs petrol, right? It needs diesel. What is that? Those are hydrocarbons. Examples of them. They are examples of hydrocarbons, right? So these are natural gases, you see. So let's try to actually understand how can we represent hydrocarbons, right? We're talking about hydrocarbons, but how can we represent them? If I want to show someone and just draw somewhere, how can I represent it? So representing um so good. So this will just be organic compounds, right? Because most organic compounds will be actually all organic compounds will be represented in similar fashion. So let's just say our organic compounds. So this will be the molecular formula, right? You can represent organic compounds using their molecular formula. So what is the molecular formula? So this is just the chemical formula, right? So this is just the chemical formula. For example, can just say, okay, so this is our chemical formula. So this shows you how many atoms do you have there, right, on your formula. For example, CH4. All right, so this is our methane that we're talking about. This is its molecular formula. We represent it like this, right? So this tells you that you only have one C atom and four hydrogen atoms. This makes sense, right? Because we say that carbon can form four bonds, right? So that means that it's forming single bonds with hydrogen. So it doesn't have a choice because hydrogen can only form one bond, right? So so that's our molecular formula. Other examples of molecular formula could be C3, let's see, C3H8, right? That's our formula. All right, so that's a molecular formula of your structure. So that's how you write it. You can represent hydrocarbons like this or inorganic compounds like that. So when they ask you to write the molecular formula, this is what you write, right? C how many C's you have, H, how many H's you have. That's for this one is only specific to hydrocarbons because they contain carbon and hydrogen atoms, right? So for other organic compounds, it will be under the it will be some maybe like you will have an O, you will have a Br for bromine, right? But this is the basic structure, the basic definition. This is what will apply. And then you also have what is called the condensed formula or the condensed structure of your organic compound. So this condensed formula, right? So this is just a notation, notation, I mean, in which atoms are bonded to each other in as a molecule, right? In which it's also in order actually this one in which atoms are bonded to each other, bonded to each other as a molecule. Mm, right. Okay, so what does this mean? So this will be, for example, it will look something like this. So this will be your CH3. So that means that that's the first one, and next to this bond will have your CH uh 2, and then you end with CH3. This is called the condensed um this is called the condensed structure of your organic compound. So this is our hydrocarbon. So this hydrocarbon is propane, right? So that's your condensed formula, right? If they say write the condensed formula, this is how you write it. You see, so the how is this different from the first one? You may ask, how is it different from the molecular formula? It's different because on the molecular formula, you write it as C3H8, but the condensed shows you, how these are bonded, right? The C atom is bonded to three H atoms and also to this C atom, right? And this C atom is bonded to two H atoms and to this one, right? And then this is bonded to three H atoms. So it shows the notation in which atoms are bonded as a molecule, right? And the molecular formula will show you how many you have in that molecular formula, in that molecule, right? So number three, so this is another way to represent organic compounds. So this is the structural formula. This is the easiest one and it makes things simple, right? If you represent your organic compounds in the structural formula, it's easy to condense them and to have a molecular formula for them. I will show you why, right? So this also shows you what all bonds between the atoms, right? Between the atoms in a molecule. Uh, right. So this, for example, we have already talked about C3H8, right? So this is how you represent it as a structural formula. We have C, right? Uh, you have another one, you have another one, right? And then you have your H atoms. This is a hydrocarbon, right? This is propane, but we'll get to why this is called propane, right? That's a nomenclature. So that's a nomenclature for hydrocarbons. So we'll get to that the naming part. So you don't have to worry about that for now. So we can count one, two, three matches with these ones, right? And then we have one, two, three, five, seven, eight matches with this right? So let's say you know this, right? You're given the structural formula, and that means you can move to say, okay, I have three, right? Three, I have H8. This is the molecular formula, right? Okay, what is the condensed formula? I have C, that one is bonded to three. Okay, three, I have another C. So you kind of move from the left to the right, right? That's the best way to move. Can also move from the right, but let's just move from the left, right? So this is our CH2 because we have only two bonds, two hydrogen compound atoms, and then we have CH3. this is the condensed formula of that structural formula. So this is one, this is two, this is three. This is all different ways on how you can represent your molecular compounds, right? So that's how you do it. Um, that's it, right? That's it. So the fourth one, this one will depend mostly on what you have at the top there, but you can also move from this one to all of those three ones, right? So this is called the general formula, right? So this is unique to every group of your organic compounds, right? We'll understand it better as we move. So this one will be like let me just give you an example. So in mathematics, right, and our what is this? Say number series, number patterns. Forgot it's the first topic in grade 12 and also in grade 11. Number pattern, yes, number pattern. And number patterns, you have you have this, right? You have n plus 1 multiplied by d. Is it plus 1 or minus 1? I'm not sure, right? But you get the idea. So we could have this as what? As n. So we could have this as 2n plus 2. This is a general formula of a series, right? So in chemistry, organic chemistry, we also have a general formula, right? But you can guess that instead of having numbers here, right, you will just have your atoms. For example, uh, let's just look at our atom here, CH3, C3H8. We've been looking at it a lot, so it makes things easier for us, right? So you can have a formula for this, a general formula which says Hn, and then 2n, um, 2n1 plus 2, right? So this is the general formula. If this makes it easier, for example, if you have a long chain to actually understand how it looks and also to draw it, right? So you can represent this as a general formula. So you know that if you have three, let's say you have uh, three carbon atoms, so this will be a three there. You know that this will be 2 by 3, 6 plus 2, so you know how many H atoms you have. So you don't have to count them. You see, for example, I know I have one, two, three. So instead of counting one by one, the general formula helps me to do what? To actually understand how many hydrogen carbons I have, right? How many sorry, hydrogen carbons I have. Yes, that's true. So that's what the general formula is. So on our video today, what we'll learn, let's just recap. We'll learn about hydrocarbons, right? These are compounds containing only carbon atoms and carbon atoms and hydrogen compound atoms, right? Their uses, natural gas, fuel, and to represent them or organic compounds as a whole, but this is mostly about hydrogen carbons, right? So we'll get to the other ones. We have the molecular formula. So this just show you how many molecules we have in there, a representation of the molecular and it numbers, right? For example, so this is how we have seen this before. H2O, CO2. Those are called molecular formulas, right? But when you break them down and we have condensed the formula, so this is the notation in which atoms are bonded to each other as a molecule. So this shows you that this first C atom, right, that you have in this three is bonded to three carbon atoms and one it's bonded to three hydrogen atoms and one carbon atom, and this one to two H and one and two C's. This one to one C and also to one to three hydrogen carbon. So those are called a condensed formula. And then you also have a structural formula for organic compounds. So you can represent them in four ways, right? We also have a structural formula. So this is the third representation where you just draw the bonds, right? So you just draw the structure, how it looks. You show your bonds, how many bonds you have. So this is the simplest way on drawing them. And this from here you can move to the condensed, you can also move to the to the molecular formula. And then we have the general formula, which makes it simple by trying to compare it to a general formula in number patterns, right? You have Tn, Tn is equal to A into N plus one, which I doubt is plus one. I think that's minus one. So I'll just have to look at to revisit my number pattern. But what I'm trying to explain to you is that in the same way that we have a general formula that you can use to see, okay, and if I have a series with 10, okay, the 10th, now what is the 10th value of a series? I can find that, right? So in chemistry, we say if I have four carbon atoms or three carbon atoms, how many hydrogen carbons, how many hydrogen atoms can I have in there? That's the general formula, which brings us to what? To us finding the molecular formula and also the other formulas, right? So that's our representation, and then we're done for today. On the next video, we'll be looking at the different types of hydrogen compounds, right? Alkenes, and alkynes. What are they called, right? So we'll be looking at them, and we'll also be looking at the naming of hydrocarbons, right? So this is what we have for this video today. Let's meet again.